problem of the day right here. This is it. And y'all have all lots of time. Y'all have 2 hours of time you owe me. And then I'm probably going to make the first day that you're back next week a day to work on these some more, because I think you're going to need it. This is 3.7, and it's number 42, which is not on y'all's sheet. Number 42, the moment of truth. 3.7, number 42. I have the equation. Y equals square root sine x plus cosine x. And I have the x value of pi over 4. That's the information that's given to me. And this is a point on the curve. We want this to be a point. So we're going to need to find a y value so that the pi over 4 is what? On the curve. I want you to write me an equation of the tangent at x equals pi over 4. And then I want you to write me an equation of the what? Normal. After that. All right? This is a chance to see if you know your unit circle. While you're doing that, I am not supposed to handle paper and then hand it to you. So I'm not. I'm just going to take a big stack of this, set it up there and see if you want it. That way, you can do this. All right. If you do not have a unit circle from last year with all the trig rules on the back written out where you can read them, not that plus or minus stuff that's on the page, got some. If you want some pages to write rules on, I would suggest you take one of these pretty colorful pages and you write your derivative rules on it that we've got so far. Because you're up to about 10 or 11, right? And, you know, write them neat. You know, if it's a, you don't have to write quotient rule, product rule probably, but you might want to put your trig ones together, but then definitely write out formal, chain rule, power rule, right? Okay? And what I would do is I would pick different colored pages that you like, that you can keep up with. Because really what I want you to do is have this for next year so that you can put this in your calculus book in college, whether you're taking Calc 1 again or you're taking Calc 2, you put it in that book and you have it there so that when you start needing it, you can find them. Okay? Use it as your bookmarks. Unit circle ones, I ran off some there. And if you don't like touching the piece of paper that's on top, because I just handled it, pour you one out of the bottom. Don't everyone run over there at once though, because we've got to stay spread out, right? Okay? But, and if you don't want to, don't. But I think it'd be really handy to go ahead and start doing a page. And then when we get to other topics, we're going to do pages for those. Has anyone got a y value yet? Sir?
The whole square root of 2 over square root of 2.
Oh, yeah, it's really just square root. It's the square root of square root of 2 over 2 or 1 over square root of 2, right? Either way. I would have written it 1 over square root of 2 plus 1 over square root of 2. And I would have gotten square root of 2 over the square root of 2. And I realized this just equals square root of 2. Is that cool? Yeah, if you get something like that, you need to rationalize it and see that's just what? Square root of 2. Matter of fact, if you'd have written it the other way, and you put square root of 2 over 2, and use this as your values, you'd see real quick it's the square root of what? 2. Don't write that. Everybody happy with the 2 to the 1/4? Yeah, because it's 2 to the 1/2 raised to the 1/2. There's your y value. And then all you gotta do is find your slope. In order to find your slope, you must take the derivative, right? And that's a big old chain rule. So you put it all in parentheses to the 1/2. Big power rule. You find the slope. Then what is the slope at pi over 4? What y'all get is the slope at pi over 4? What's the slope at pi over 4? Put pi over 4 in there and find out what the slope equals. What is the slope equal at pi over 4? Someone always frowns at me when I'm working, but I can't see the frown under their mask, but they just have in their eyes, Mr. Evans, we already know this. This is too easy. I want one of those folks to tell me what is the slope at pi over 4? 0. Yeah, the slope's 0. So look, right here. Cosine of pi over 4 minus sine of pi over 4 is going to be what? 0. 0 times all that's going to be 0. So when you write the equation, it's a horizontal line. So the tangent is y equals 2 to the 1/4. Wait. Yeah, it's got to go through that point of slope. So y equals 2 to the 1/4 is your tangent line, because it's a horizontal line, right? Is that okay? Tangent line's horizontal. And then the normal line's a vertical line. So it's what? X equals what? Pi over 4. And there's your normal. Okay, the slope is what? 0. So if you have a 0 slope, you have a horizontal line that's touching that y value. Your normal is a vertical line, and what value is it touching? That value. How many of you are able to get the slope as 0? You see the slope really equals 0. How did I get? I don't want to point at anyone and say how to get the slope equals 0. That's kind of mean for me to do. But I'm worried. Yes, sir?
Can you explain how you got from y equals sine x plus cosine x? Yeah, that's right.
Yeah. Okay, I brought the 1/2 to the front. I wrote it all down, negative 1/2, subtracted 1. And then don't forget, you have to take the derivative of this.
Yeah, how do you get
Derivative of sine x is cosine x. And derivative of cosine x is negative sine x. And that's the reason you want to put your trig derivative rule on one of those sheets like I suggested, right? You want to make a rule of all your derivative rules that we've got up until now. And that way, and since you've already learned how u and du work, I could actually have you find the derivative of terms that you don't even know what they mean, but you could find the derivative if you had the derivative rule. Okay? Because they all have a u part and a du part. And that's what we want to get to, is where you can use the rules. All right. I'm done for the day. You've got